All right, let's get started with 3.6, modeling functions using variation, the last section of chapter 3. So there are 4 types of variation that we're going to focus on today, and the big 2 are direct and inverse variation. Combined and joint variation we'll touch on as well. All right, so there's 2 big formulas you need. Direct variation, you have a formula here, y equals kx, and inverse variation, y equals k over x. K is going to be known as the constant of variation. So our job here is to figure out a number for k. Okay, so let's get going. So first up, we're going to do direct variation. So again, our formula is y equals kx. So 2 ways to say this. We can say y varies directly with x, or y is directly proportional to x. All right, so either way works. So let's take a look at an example. In the United States, the cost of electricity is directly proportional to the number of kilowatt hours used. Okay, we're going to break down this sentence. The cost of electricity, so we're going to say C, is your equal sign. As soon as we see directly proportional, we want to put K. C equals K, and then directly proportional to what? To the number of kilowatt hours used. So I'm going to pick W here since we already used K. So C equals KW, right? So cost of electricity, first variable, is equals directly proportional, put RK, and then what's your last variable? In this case, it's the kilowatt hours, which we write W. All right, so let's put our data in. So a household in Tennessee used 3,098 kilowatt hours. So instead of W, we're going to put 3098. We've got K here, and the cost was $179.99. And our job is to get K by itself. So what do we need to do? We need to divide both sides by 3,098. And for this, let's grab our calculator. So this was $179.99 divided by 3098. And we get 0.058, and we'll round it off there. So K equals 0.058. All right, so we need to find the mathematical model. Our job is to rewrite this initial equation, excuse me, with everything exactly the same, but a number for K. So C equals 0.058 times W. That's our mathematical model. All right, your turn. See if you can do it right here. Okay, so hopefully we wrote C equals KW again. And we have 4,000 for our kilowatt hours. And that cost us $480. So we'll divide both sides by 4,000. Let's go grab our calculators and do 480 divided by 4,000. 480 divided by 4,000 is 0.12. So C equals 0.12 W. Okay, so this works as well with powers. So you can be directly, you can have direct proportionality with a power in your variable. So in this case, weight in humans in pounds is directly proportional to the cube of height. Right? So there's height cubed. So we're going to use this here. Weight is directly proportional to the cube of height. So let's see here. So we have a single professional male seeks single professional female for long-term relationship. Must be athletic, smart, like movies, dogs, probably long walks on the beach, etc., etc. And here's the weird part of this. Have height and weight similarly proportioned to mine, an odd request. All right, let's find a mathematical equation to describe this odd request. So we have a male who is 194 pounds. And let's figure out what the K is. His height is 6 feet cubed. So 6 cubed is 216. We'll divide both sides by 216. So 194 divided by 216 is 0.90. We round. So now we have a model. W equals 0.90 h cubed. All right, so how much would a 5'6" woman weigh to have the same proportionality? Okay, so we have a woman who is 5'6". Need this in feet, so this is going to be 5.5 feet cubed, and we got to figure out her weight. So let's take 5.5 and cube it. 5.5, and we'll go to the third power. Where's our caret? There it is. To the third, and we're going to times it by not the rounded answer, but the exact answer. Note that on your calculator, you can press the arrow key, the up arrow key, and grab a previous answer by hitting the enter key. There it is. And that is 149.42 pounds. We would round down 149 pounds. All right, your turn. See if you can do it. Okay, so again, on this one, we have weight equals kh cubed. And the sister is 6 feet tall, and weighs 170. So we'll divide by 216, which is what 6 cubed is. And what's 170 over 216? 0.787. All right, her brother is 6'4". How much does he weigh? So his height and that would be 6.33, repeating, because 4 inches is a third of a foot, and we got to cube that. So 6.33. We'll do a bunch of them there. Won't be perfectly exact, but pretty good. To the third, and then times our previous answer. And I believe I forgot the times button. 6.333 cubed times our previous answer. And there we go, 199.93, so we'll round up to 200 pounds. Okay, so just a note on this, we're not going to do an example on this one, but we can on this one. Oh, you know what? We are going to do one later on. Scratch that. Let's dive into inverse variation. So this is an example where one thing goes up as the other thing goes down. All right, and so our model here is y equals k over x, and this is inverse variation. So an example here is, as the price of a house goes up, the number of people that want to buy it would go down. So in this case, if they are inversely related, if the number of potential buyers, so we're going to say buyers equals k, and this time it's inversely proportional, k over the price. So let's pick a match here. I'm going to pick this one right here. So the number of buyers is 500, and the price is $200,000. And so we're going to multiply both sides by 200. And so 2 times 5 is 10 with 4 zeros. That's 100,000 is K. And so how many potential buyers will there be for a $2 million house? So we're going to solve for buyers. So this is B equals K, we know, 100,000, over 2 million, but remember this is in thousands of dollars, so here's how you write 2 million. So that is 2,000 thousands to get there. And so let's cross off the zeros there. 100 divided by 2 would be 50. There are 50 buyers interested in this house. Okay? All right, so your turn. See if you can figure this out. All right, so the number of potential buyers is inversely proportional to the price of the house, so equals K over P. There are 12,500 potential buyers for a $2 million condo, so K over. And in this case, let's do it in thousands again. So say 2,000 thousands is $2 million. And so if we multiply these together, 2,000 on both sides. So 2 times 125 is 250. We have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. So that's 25 million is your K. And again, that K doesn't mean anything. It's just the ratio that's used in these equations. So let's redo this. And we're going to figure this out for a $5 million condominium. So we're going to say how many buyers are available if we wanted a $5 million condo. So that's 5,000 thousands. And we'll cross these off here. And 25 divided by 5 is 5 with the 3 zeros. So 5,000 buyers would be interested. All right, so this is the example that we're not going to do. You can also do powers with inverse variation. So just so you're aware of that, we're going to move on. All right, so joint variation is direct variation with multiple variables. So simple interest is an example of this. You have multiple variables on the other side. So if interest is fixed, if price goes up, the other values would have to fall to keep things the same. So let's see an example. The gas in the headspace of a soda bottle has a volume of 9 milliliters, pressure of 2 atmospheres, a temperature of 298 Kelvin, and if the soda bottle is stored in a refrigerator, the temperature drops to approximately 279 Kelvin. So what's the pressure of the gas in the headspace once the bottle is chilled? Okay, so combined variation, we've got the gas in the headspace, okay, and let's see, so pressure is going to, they don't tell us what the formula is on this one. So I'm going to pause this and go grab it for us. 1 second. All right, here we go. So pressure is directly related to the temperature and inversely related to the volume. So let's put some formulas in, or some numbers into our formula. So we have a volume of 9.0, so that's going to be in the denominator. So 9.0 down here. We have a pressure of 2 atmospheres. So we're going to have 2 over on the other side. And then we're going to have a temperature of 298. So 298 here. All right, so we'll do 298 divided by 9. Calculator. 298 divided by 9 is 33.11. We'll get this out of the way. 2 equals K times 33.11. We'll divide both sides by that. We're going to say 2 divided by the answer we just got. And so 0.06 is what K equals. And so now we're going to figure this out again. What is the pressure of the gas? We're solving for pressure. We've got 0.06 is our K. In the headspace, once the bottle is chilled, so we drop down to 279 Kelvin. And in this case, the volume stayed the same because the bottle didn't change. So let's plug these in. We're going to times by 279. And divide by 9. And we get 1.87. So the pressure dropped from 2 atmospheres to 1.87 atmospheres. All right, that will do it for variation. Good job getting all the way through chapter 3.